Good day, sir. I am the Cadet Abarkis Christian Joy, and we are Group 1. And these are my group members: Armanel Justin, Cantuna Rigi, Contrelon Christian Ed, Contento Luis, and De Los Santos Unicis. So, for my given topic, sir, which is part of the sextant. So, first, sextant. What is a sextant? A sextant is a double reflection navigation instrument that measures the angular distance between two visible objects. The primary use of the sextant is to measure the angle between the astronomical object and the horizon of the for the purpose of the celestial navigation. So next is index mirror. So the index mirror is the rectangular in shape and sit in a frame attached to the movable index arm. When properly adjusted, it should be perpendicular to the plane of the instrument. Its purpose is to reflect light to the horizon mirror. So next is the telescope. So the telescope direct the line of the sight of the observer to the horizon glass and magnifies the object observed and parallel to the plane of the instrument. So next is the telescope clamp. So the telescope clamp is the reinforcing circle that attach the telescope to the sextant. So next is the eyepiece. So the eyepiece is the length through which the user looks through the telescope. So the eyepiece is the lens through which the user looks to the telescope, sir. So next is the telescope printing. It is the tube attaching the eyepiece to the telescope, which can be twisted for length adjustment. And finally, sir, for my topic, which is frame. So the frame is the structure that serve as the base for the different parts of the sextant. So that would be also for my given topic, sir. Thank you.
So next, the graduated arc. So the function of graduated arc from the sextant is that it indicates the number of degree of an angle. So next is the locking device. So from the word itself, locking device, so it holds intact of the sextant in place. So next, the drum or the micrometer drum. So the function of this is that it rotates to make fine adjustment when measuring angles and indicates minutes of a degree of an angle. So next, the index arm. So the function of index arm is that it determines the direction or measure of an angle. So next, the glass filter. So this is the glass filter for the index arm. So the function of this is that it prevents us or it protects us from the rays of the sun. So next, the horizon mirror. So the function of the horizon mirror is that it allows the observer to view one object directly on one side while observing a second object reflected next to it. And lastly, the glass filter of the horizon mirror. So the function of the glass filter of the horizon mirror is the same as the glass filter of the index arm. So it helps us to protect our eyes from the rays of the sun. So next, reporter.
Errors of sextants. Adjustable error of sextant. First is error of perpendicularity. So, error of perpendicularity is produced by the index glass not being perpendicular to the plane of the instrument. Second is side error. That error in the reading of marine sextant due to a non-perpendicularity of the horizon glass to the frame. Third is index error. Index error is your code is trying to access an index that is invalid. And next is by observing the horizon, by observing the star or planet, by observing the sun. And last is error of collimation. Error of collimation is occurs when the axis of collimation is truly horizontal when the instrument is level.
Good day, sir. I'm Cadet Contrillion. I'm going to report about the non-adjustable errors of sextant. So there are 5 non-adjustable errors of sextant. First is the graduation error. Graduation error is the result of inaccuracies in the machining of the arc, micrometer drum, and the vernier of the sextant due to the inaccurate graduation of the main scale. Next is the centering error. Is caused due to the pivot of the index bar not being coincident with the center of the circle of which the arc is a part. So optical errors may be caused by prismatic errors of the mirrors or the aberration of telescope lenses. The third error is the shade error. Shade error is the shades should be so mounted that the glass surfaces are normal to the rays of light passing through them. So if not, the distortion would result. The greater number of shades used, the greater the chances of distortion. So fourth is the optical errors. So may be caused by prismatic errors or the mirrors or aberration of the telescope lenses. So the last error is the wear on the rock and worm. So this causes a backlash leading to inconsistent errors. So wearing down of the worm can due to the lack of lubrication. The presence of dust particles, careless handling can cause error.
So, good day, sir. I'm Decadet de Los Santos. I'm here to explain on how to correct errors of a sextant. So, these are the following errors. How to correct error of perpendicularity, how to correct side error, non-adjustable and non-correctable errors, shade error, prismatic, graduation error, worm and rock, centering, and culmination. So first is how to correct error of perpendicularity. So these are the steps. So first is bring index bar of on the middle of the arc. Second, hold sextant horizontally, arc away from you, and look at index mirror. And third is the arc must appear as one single line. So fourth is adjust by a screw on the back of the index mirror. So next is how to correct side error. Side error must the index bar at 0, always 0. So next is non-adjustable, non-correctable errors. So non-adjustable and correctable error is we can't correct these errors. So all non-correctable and adjustable errors will be mentioned in the certificate inside the sextant box. So next is the shade error. Shade error, faces of the shades not parallel to the ground. Next is the prismatic. Prismatic, when two faces of the mirror not parallel to each other. So next is graduation error. Graduation error, incorrect scale on the arc, vernier or micrometer. So next is worm and rock, damage to the gearing rock. And next is the centering. Centering, pivot of index arm is not at the center of the curvature of the arc. So last is the collimation. So collimation axis of the telescope not parallel to the plane of the instrument. So that's all, sir, about my topic. Thank you for listening.
How to correct the errors for a sectant. The light is reflected twice in the same plane from the direct snipe to the horizon mirror, then again to the horizon mirror to the telescope. In these circumstances, the angle between the first and last direction of the ray of light is twice the angle between the index and horizon mirrors. This principle is based on the first law of light. When a ray of light is reflected from a plane mirror, the angle of incidence of the ray equals the angle of reflection.